Good morning, everyone. Um, Today we will be talking about number systems, that is Module 5. Today's class is very, very important. It is very, very important. Okay. Today's class is very, very important in preparation for your IP addressing, and subnetting classes. So you need to take today's class very, very serious if you want to survive this course. We'll be talking about number systems. We all know these are the two topics, binary number systems and hexadecimal number systems. Binary and IPv4 addresses. Binary numbers they consist of zeros and ones only. Binary numbers consist of zeros and ones, and decimal numbers consist of 0 through 9. Okay? 0 through 9. Right. So in essence, binary numbers are base 2 and decimal numbers are base 10. So why do we have to study these binary number systems? You should understand that computers, servers, and network equipments only understand binary numbers. They only understand zeros and ones. Okay, they don't understand any other thing except zeros and ones. So an IP address is a string of 32 bits. An IP address, you'll see an example of an IP address. Today I'll give you a demo on the board because you need to understand this very well. An IP address is a string of 32 bits that is divided into 4 sections. An IP address is a string of 32 bits that is divided into 4 sections, and each section is called an octet. And each octet contains 8 bits. Okay, an IP address is a string of 32 bits divided into 4 sections. Each section is called an octet, and each octet contains 8 bits. 8 bits is equal to 1 byte. So these 4 sections are separated by dots. Okay? These 4 sections are separated by a dot. All right? Let's move on. Hello, L. Hmm? Hmm? Okay, no issues. So, sorry guys for that. Binary positional notations. Okay? In binary positional notations means that a digit represents different values depending on the position the digit occupies in a sequence. So the position that a digit occupies in a sequence determines the value of that digit. Okay? So if you look at here, look at this first box here, we have radix, this is base 10. Okay? These are the positions 0, 1, 2, 3, 4. Okay? Because it is to the power of 10. Or the base is 10, it's a base 10 radix, and these are the positions 0, 1, 2, 3, 3. So if you look at this, 10 raised to the power 0 is 1. In maths, we have been told that any number raised to the power 0 is 1. So 10 raised to the power 0 is 1. 10 raised to the power 1 is 10. 10 raised to the power 2 is 100, and 10 raised to the power 3 is 1000. Okay? Sorry. So the same thing is done here. All these values are calculated. You can see thousands, hundreds, tens, and zeros. Okay. 4 times 1 is 4, and then 3 times 10 is 30. So all those values are add up here, and you are given 1,234. So this is still a continuation. Now we're talking about base 2. Okay. Like I told you, decimal numbers, they are base 10, and binary are base 2. So now we are going to binary numbers. They are base 2. So these are the positions, 0, 1, 2, up to 7. So base 2, 10 raised to the power, so 2 raised to the power 0 is 1, 2 raised to the power 1 is 1, and the same thing goes. You can see. So these are their positional values. These are their positional values. And then you can take all these positional values and add them up. It is going to give you this value, 192. If you are finding it difficult to get this, don't worry, because I'll do a demo on it. I'll use a whiteboard with a marker to give you more explanation on this. If you are finding, for some of you who are seeing this for the first time, I understand it may be a little bit difficult for you. Okay. So this is called converting binary to decimal. Like I told you, binaries are zeros and ones. How do you convert binary to a decimal value? Okay. So depending on the positional value, you can see the positional values up here. See, these are the positional values: 1, 2, 4, 8, 16, 32, 64, and 128. So take the binary value that you are asked to convert. Here you have to convert this binary value, 110000. Put it below the positional value like this. So you have to take the positional values. So here, if there is 0, there is no need for you to take the positional value. When it is 0, you don't count the positional values. But wherever you have 1, you count the positional values. You can see here, 1 here has a positional value of 64. This one also has a positional value of 64. So the binary conversion of this to decimal is going to be 128 plus 64. You can see it here. 128 plus 64, 0, 0. Okay? Guys, let me know if you are finding it difficult there, okay, please. You can unmute yourself and talk. So in essence, when you're trying to convert binary to decimal, you use the positional values. The positional values are here, okay? 2 raised to the power 0 will give you 0. Sorry, 2 raised to the power 0 will give you 1. 2 raised to the power 1 will give you 1, 2. 2 raised to the power 2 will give you 4. 2 raised to the power 3 will give you 8. 2 raised to the power 4 will give you 16. So these are the positional values. So if the position, if the binary is 0, you don't count the positional value. Just take 0 times 1 will give you 0. 0 times 2 will give you 0. 0 times 4 will give you 0. You can see. But 1 times 64 is 64, and 1 times 128 is 128. So you are going to add up these values here. So 128 plus 64 is going to give you 192. So the next binary value you have to convert is here. Okay? The next binary value you have to convert is here. 1010100. Put it below the positional value. So wherever you have 0, 0 times 1 is 0, 0 times 2 is 0, 0 times 4 is 0, 1 times 8 is 8, you can see. So you have to add all these values, and it's going to give you 168. The same thing happens here and then here. So at the end of the day, what we have as a decimal conversion of this binary is 192.168.11.10. This is an example of an IP address. Guys, I hope it's clear.
Yes, yes.
Hello, guys.
Uncle Yanko, I'm confused.
You're confused, huh?
Yes.
What is confusing you? What don't you understand? Tell me. Who else is also confused? Drame, Hassan.
Complicated, yeah.
Hassan, are you okay with this binary to decimal conversion?
Yes, sir. Yes, sir. I'm okay with it.
Yeah, okay with it. Wonderful. Because this thing, why I want everybody to know
Yeah.
this, it's very important in IP addressing and in subnet calculations. So if you don't get this, you'll find it very difficult when subnetting. I mean, you said you are confused. What is confusing you? What don't you understand, to be specific? But if you don't mind, like I told you, I'm going to give you, a demo on the board where I'll use a whiteboard and a marker to help you understand more. Okay?
Okay. Okay.
Can we move on? Mamadou, who is Mamadou, you've been quiet, huh?
You want to pick in? I think maybe I am.
Mamadou.
Hello, Youngs.
Yes.
I was thinking.
Huh?
I was thinking. I just have a suggestion to make.
Okay. Okay.
What I was thinking, it's like, the binary numbers. I think for them that have not used these binary numbers, it will be very difficult for them to understand this.
Exactly.
It would have been very easy for you to start from 0 to 15. I think that's the primary ones. It would have been very easy for them to understand from 0 to 15. I think they will be able to convert this, 192, then 168, and the rest.
I think I need to put on my headphone. I don't know. Maybe say you are not speaking louder. I find it difficult to get you.
Oh, okay. Okay.
Yes.
I'll...
Just 1 second. Let me put on my headphone. Okay. Okay. Sir, you can go ahead. Yes.
Yes. I was thinking.
Yes.
It will be very difficult for them that have never used this binary decimal conversion for them to understand this.
Exactly.
It would have been very easy if we start from 1 to 15.
Yes.
You show them how to calculate from 1 to 15.
Yes.
I believe it will be very easy for them to be able to do the rest.
Yes, yes. Maybe in subsequent slides we will see them, but like I promised, right from this lecture, I'll just use the whiteboard and a marker.
Marker and explain how. Okay,
yes,
fine.
Exactly, and I think that is going to help a lot. Slides. I'm just following the slide, so whatever is in the slide.
This is very important.
It's very important in IP addressing and subnetting. So if you don't get this, you cannot survive that class.
Thank you.
All right, let's go. So we move on to the next slides. We have dealt with binary to decimal conversion. Now we are into decimal to binary conversion. Okay, we already dealt with binary to decimal conversion. Next step now is how do we convert the decimal to binary? That is it. So this is like in programming, maybe you call this what a flow chart. They have designed a sort of a flow chart for you here. You just use the logic and follow the principles of this flow chart. You can see your positional values here. These positional values are very important. 1, 2, 4, 8, 16, 32, 64, and 128. These are your positional values. So when you're given a number, a decimal number, to convert it to binary, what you do is, for instance, they said you start with this highest position. When you're given a number, you start with the highest position. Okay? Let's say what number is given to you. First, it says start at 128 position, the most significant bit in the decimal number of the octet equal to or greater than 128. Okay? If a particular decimal number is given to you, check, for instance, whether it is equal to or greater than 128. Check whether that number is equal to or greater than 128. but 128 is the most significant bit here. Okay, so for instance, you are given this value 64. You are given 64, so you are going to check whether 64 is equal to or greater than 128. Okay, you're going to check whether 64 is equal to or greater than 128. If the condition is yes, you have to add 1 to this box here. If the condition is yes, you have to write 1 below 128. If the condition is no, you have to write 0 here. I hope it's clear. Okay? If the condition is yes, you go this way and write 1 here. But if the condition is no, you add a 0 here. Okay? Then they're telling you if yes, record 1 in 128 position and subtract it. If it is yes, you record 1 and subtract 128 from 64. When you subtract 64 from 128, how much you're gonna be left with? Another 64. So you move to the next position and do the same thing. Compare this 64 with this 64 and see whether it's equal to or greater than it. If it is yes, write 1. If it is no, you write 0. Okay? Guys, sorry for the first time, huh? But we will do this. You're gonna love it, huh? So if you look at this, they said convert 168 to binary. You want to do it here. Is 168 equals to or greater than 128? Yes, 168 is obviously greater than 128, so we write 1 and subtract it. Guys, who is going to be with, who is good in maths here? Who can help us? Who are the mathematicians here? 128 from 168. You're going to be left with what? Is it 40? I think 40. Correct me. Yes. You're going to be left with 40. So now we check that, we cross-check that's 40 with 64. Is 40 greater than or equal to 64? No. 40 is not equal to 64 and 40 is not greater than 64. So we write a 0 and move here. Is 40 greater than or equals to 32? Yes. 40 is greater than 32. So we write a 1 and subtract it. If you subtract 32 from 40, you have 8. You cross-check that 8 with 16. Is 8 greater than or equals to 16? No. You write a 0 and move. Is 8 greater than or equals to 8? Yes. 8 is equals to 8. You write a 1 and move. So now you have no remainder. All of them should be 0.
Youngs.
Yeah, man.
This one is okay, but I believe there is another method that will be simpler to do. I think it will be easier for everybody.
Some of them, yeah. You have a hell lot of even the concept I know is different from this, but I'm just following the slides.
Oh,
but
okay.
You have a hell lot of methods to do this. Simple way. So whichever works best for you is the best method for you. Even the method I always use is different from this, but this is what the slide is giving you.
Okay,
but there are different ways you can do this. You remember even in senior school, we used to draw that line and then we say remainder, and then
yeah, and I believe that one is even easier.
Yeah, so that's why I said there are a hell lot of the long division. You call it long division, right?
No,
yeah, so there are a hell lot of different methods of doing it. I agree with you. Yeah. But I'm just trying to follow the slides. Maybe when I get to the whiteboard, we can try all the different methods there. Is that okay?
Yes, no problem.
All right. So you can see why we are doing this. Like I told you, computers don't understand decimal numbers. They understand binary numbers. So if you give computer this address 192.168.10.10, the computer is going to convert it to the decimal format to be able to use it. So you can see this is an example of an IP address 192.168.10.10, but it is converted to decimal format. So this is the decimal representation of 192, the decimal representation of 168, decimal representation of 10, and the decimal representation, sorry, the binary representations. These are the binary representation of 192, binary representation of 168, binary representation of 10, and binary representation of 10. So you can see the importance of this, why we're doing this. So we are done with decimal to binary and binary with decimal. Now we move to hexadecimal numbers. Hexadecimal numbers, they are of base 16, right? Base 16. Okay. Why you have to do hexadecimal numbers? Because if you go to IP version 6, you deal with hex values. In IP version 4, you don't deal with hex values, but by the time we get to IP version 6, we have to use hex values. That is why you need to understand hexadecimal too. So they said hexadecimal is base 16. You can see it's a base 16 numbering system using 0 to 9 and then A to F. It's a base 16 numbering system. It uses 0 to 9 and then A to F. Okay? So it is easier to express a value in a single hexadecimal digit than a 4 binary bit. So hex, okay, in MAC addresses also, you will see hex values too. MAC addresses or hardware addresses of devices, you will see hex values. They also use hexadecimal values. So you can, if you look at these 3 columns here, the binary representation of 0 is 000. The binary representation of 1 is 001, you can see. And the hex value is also 0, 0. The same thing goes. But by the time you get to 10, the hex value is going to change to A. Okay? The binary representation of 10 is 1010, but the hex value is A. So in the hex value, if you get to 9, the next one is A, B, C, D, E, and F. Okay? So this is an example of an IPv6 address. IPv6 address is 128 bits. We said IPv4 address is 32 bits. IPv6 address is 128 bits. Okay? Every 4 bits is represented by a single hexadecimal digit. That makes an IPv6 address a total of 32 hexadecimal values. So these are examples of our IPv4 address. It is, separated by a colon of 4 digits. You can see every X is 4 digits. Okay? So it will start from 00 to the final one, FF. You can see the highest value is F. It starts from 00 to FF, you can see. The highest value is F. Okay?
No.
Decimal to hexadecimal conversion. How do we convert a decimal value to a hexadecimal value? It says, convert the decimal number to 8 bits binary string. Divide the binary string in groups of 4, starting from the rightmost position. Convert each 4 binary number into their equivalent hexadecimal digits. Okay? First, you take the hexadecimal value, convert it to 8-bit binary. After converting it, you group them into 4s. Binary strings into 4, starting from the rightmost one. Each 4 binary number is an equivalent of a hexadecimal. So here you can start with this, an example, 168 convert to hex using 3 steps. When we convert 168 into binary, this is what we are going to have. 10, 10, 100. So this binary in 2 groups of 4, you can see, you take 1010, make it a group, and then 100, another group. Okay? So if you look at 1010, in hex value is A. If you look at 100, in hex value is 8. So your hexadecimal value now is A8. It's tough, right? Hello? Huh? It's tough, right? Hello? Hello?
Yes.
Who is that?
Yes.
Sir, I'm hearing somebody say Liam Jango Nago. Who is that? Sir?
Yang Kisri.
Who is that? Oh my God. Okay. Comfort. How are you?
Bye.
I think we are running out of time, but we will finish this. It's a short slide, but I'm going to use the whiteboard so that you can have more hands on this, and I'll send you a lot of assignments, okay?
Okay.
I'll send you a lot of assignments, and I expect you to do those assignments. Even if you get it wrong, we can help you fix it so that you get it under control, because this is very important for us to move to the next step. Okay, so also, how do we convert hexadecimal to, how do we convert hexadecimal to decimal? Another thing, that is the reverse. It says follow the steps listed to convert. First thing is convert the hexadecimal number to 4 bits binary string. Each hexadecimal number, convert it to only 4 bits binary string. Then create 8 bits binary grouping starting from the rightmost position. We start with this one. You can see we have D2. D2 is a hex value. So first, we have to convert D2 into 4 bits binary string. We convert D separately and we convert 2 separately. So the how do you call it? The binary conversion of D is 110, and the binary conversion of 2 is 001. So you group them together to have your, to have your binary, and then you convert the binary to decimal. Okay? So if you convert the binary to decimal, finally you have 210. That's your decimal value. I think I'll use these examples on the board. These particular examples we are seeing here, I'll share the slide with you. I'll use these examples on the board and share with you. Huh? So this is the end of today's class, but it's very important. I'll send you assignments. You try and do it, huh? Please. Is that okay? Anybody has any comment, query, or whatever? Let's go through it. Hello, LYC. You came late, huh?